Welcome back, everybody. This is Professor H here from the RIT Networking Labs, and we are talking about OpenFlow. This is part 4 in the series. So if you've been following along, welcome back, and if you're new, hey, welcome to the channel. So if you remember, this was our topology that we're working with. Remember, we just have a small OpenFlow SDN-based topology. Our controller is at 192.168.1.1, and we've got our switch, our OVS, or OpenFlow Enabled Virtual Switch, at 192.168.1.2. Now, those addresses will become important to us as we actually start to look at packets. Remember that since we're talking about messages, we have 3 different types of message. We have the controller to switch, we have asynchronous and symmetric. The controller to switch and symmetric types have already been covered. So we are talking about some of the purposes for asynchronous messages. Here is our initial connection. Remember that it just spins up a standard TCP connection. The controller is listening on port 6633, and then we have the standard SYN, SYNAC, ACK, TCP connection types. And then off we go into the hello messages. So what is the purpose of our asynchronous messages? The big deal here is that something just happened on a switch, and now the switch is going to send the controller some message as a result of that event. So something's got to happen here, and so we're going to see later on when we do our packet list how the conversation typically goes. But what you're commonly going to see is a packet in message from the switch. So the switch says to the controller, hey, I just got this. What am I supposed to do? I guess we ought to step back here just for a second and think about the kinds of topologies that we have here. And remember that in this particular topology, the controller is in charge of the whole thing. So the switch is waiting for the controller to tell it what to do. Now, once flow entries get added to OVS, it doesn't need instruction from the controller as often. You can also run what's called an uncontrolled SDN environment, in which case the switch has all this manual configuration built in. But in this particular case, control is in the hands of the controller. All right. So that's pretty much what's happening here. And here is an example of a packet in message. Now, I don't know if you caught it from the previous slide. If you didn't, go back and take a look at the video. But in many cases, the packet in message requires the switch to tell the controller not just that something happened, but, oh, by the way, here's the whole stinking message that I got. And so here is the message that we got from the switch to the controller. And you can see here that the source IP address is, in fact, 192.168.1.2. So it came from the switch. And this is a packet in, or type 10 message, and this is sent as a response to the switch receiving this particular ARP message. So if you look down in the body of the ARP message, this is between a host on the network and the gateway that's on the network. It has nothing to do with the OpenFlow channel between the controller and the switch. This is just nodes on the network trying to communicate. And the switch saw it, so it said, hey, I've got this message that happened. Here's your packet in message. Now, there are a couple of other reasons that you might see asynchronous messages. If the controller wants to update the flow table, he might make a modification. Now, this is different than the flow mod message. So this is a remove the entry from the table, or that the switch has removed the entry. The switch also might say, hey, listen, I had a port status change. I'll also recall you to the first type of message that we talked about, that is the controller to switch. And a lot of those are used for the controller to tell the switch what to do. A lot of the asynchronous messages are from the switch to the controller, indicating something happened. And so that's what these are about here. All right, so just as a refresher, all right, so what we're looking at here are asynchronous messages. So the first one that I have highlighted there is the packet in message. So that is an OpenFlow message coming from the switch that says, hey, I just saw this. The controller often responds with a packet out message that says, all right, listen, I saw that you got this. This is what I want you to do with it. Now below that, I've also highlighted a flow mod message. This is one of those controller to switch messages that describes what the controller wants the switch to do. In other words, modify your flow table to forward traffic in this form. So I show you this list, and I've pointed out these particular examples. And these packets, and in particular the packet in, packet out messages, are repeated over and over and over again. You see these all the time. And then you see these flow mod messages when something new has happened. All right, so there we have it. We've covered the three types of OpenFlow message. We've got our asynchronous that we did this time. We also have the symmetric messages, and then we've got our controller to switch messages. And all of this stuff happens over that OpenFlow channel that's running in between the controller and the switch. I've been trying to think about what to do next time. Maybe we'll talk about operations. Maybe we'll actually show you some flow tables and what those actually look like. And I've also decided that I'll go ahead and post these packet captures that I've been using for these videos up on my site. So if you want the actual PCAP files that I've been using for these, go on over to brucehartpence.com and pick them up, download them. You know, you open up Wireshark or OmniPeak or whatever your favorite tool is. Thanks very much for watching. If I helped, don't forget to subscribe and like the video. And hey, may your packets always reach their destinations.